Thanks very much for coming, everyone. It's nice to see a full room. So I'm Emily Wallace. I work at the Met Office. I've been working in long-range forecasting for around about 10 years now. Started off in the sort of science end of things, and I've had more and more interest in applying that science and making sure that it's useful. And so I'm really, really excited to be involved in this project because I think we've got a really good opportunity to spend a significant period of time to make sure that we're tailoring the information coming out of seasonal or long-range forecasts to the needs of the users and to be able to create real business value from them. So I'm going to talk about the science of long-range forecasting today. I know there's an awful lot of experts in the room, actually. How many people are not familiar with science of seasonal forecasting? Are there many in the room? There are a few. Yes, there are at least a few. Jolly good. So it may be a little bit back to basics for those who have been working on this for several years as well. So I'm going to cover, as I say, back to basics, a bit of why are they useful, what are we all doing here, and what do we mean by long-range or seasonal forecasting, how it's possible, and then a little bit about how we know it's any good, and where to go from here. I'll also cover a little bit on the science of long-range forecasting that we're applying in this project. So that's work package 2 for those who are familiar with the setup of the project. So what's the new science that we're expecting to pull through this project? Okay, so the background bit. So this is where I've tried to summarise when I think long-range forecasts or seasonal forecasts can be useful. I think it's very easy for them to be completely useless. So this is my stab at saying that this is the circumstances under which you can probably get some value from long-range forecasting, and then it's the job of this project to really exploit that value. So if your business is currently using historical weather data to make better decisions, so that might just be understanding that summer is hotter than winter in general. So if you're making analytical decisions on that, even better. I think there's a really strong opportunity to make better decisions using seasonal forecasts. If you're able to make decisions several weeks or months ahead of the sort of target date, again, that's a requirement for seasonal forecasting to be useful. If you're not making decisions or at least changing your mindset ahead of the time, then really what are you looking at a long-range forecast for? The ability to hedge or adjust decisions as time evolves. So hedging might be taking a decision over several years, so using a seasonal forecast over several years to exploit the value. Because they're probabilistic, they're necessarily uncertain. There has to be some element of hedging or ability to adjust your decision, because it's not going to give you a solid answer as to this season will look like exactly like this. So the ability to hedge or adjust decisions is really, really important. And if those points apply to you, then the benefits you could be getting are an increase in confidence. So if you're currently using analytical use of climatology, a long-range forecast could increase your confidence, literally just reduce the uncertainty in that climatology, in that sort of spread of historical weather that you're using. Increasing your confidence could reduce your costs and reduce your risk. So that's the sort of business value that we're expecting to see from long-range forecasts applied effectively. So what do I mean by seasonal climate forecasting? So I thought I'd spell it out word by word. Seasonal, so if we're talking about seasonal, then really we're in the time span of making a forecast for a month ahead out to around about 6 months ahead. So shorter than that would be probably medium range forecasting. Longer than that, you'd start for decadal forecasting. We're really in that sort of 1 month to 6 months ahead type timescale. It's a climate forecast, so as I say, it's not going to tell you exactly what weather might happen. It's about telling you properties that the weather that's coming is likely to take. So something like the average temperature in a summer, the number of windy days in autumn, and this is really the element where we'll be doing the most tailoring. So what is it that your businesses need to know about in order to make decisions, and trying to get as much information from the seasonal forecast as possible through this project. So forecasting, we're talking about the description of the likely climate outcome. So we're saying something more than this is the normal range of weather or climate that you might expect in the season that you're interested in. As I say, it's necessarily going to be probabilistic. When we're looking this far ahead, there will never be an ability to predict a particular day's weather. So we're talking probabilistic forecasting here, and that needs to be taken account of as how we make decisions. So as I say, back to basic slides. So how is seasonal forecasting possible? On the right-hand side there's a schematic diagram indicating what many of us probably know intuitively, that weather forecasts can't be skillful for more than a few days, in the sense that the atmosphere is not predictable for more than a few days. So the relevance of the initial conditions, you could say it scientifically, or just the predictability of the atmosphere drops away quite quickly after a few days. So you can imagine that a little bit like dropping balls into the top of a pinball like this. After a few days, so after a few bumps through these pins, you don't know where that ball's going to land. Aligned with that, you can understand the weather, the climate of the weather, the climatology of the weather, what the weather normally does, and you can understand where these balls normally drop in this pin table. So you can build up a picture of what normal looks like with atmospheric conditions and with balls in a pin table. So in seasonal forecasting, what we're looking at is a situation a bit more like this. So we've got a pin table that's been tipped. Now we can build up a picture of where the ball is likely to land, and that might be a little bit more certain than previously. It might be much more likely to land in that right-hand corner, and that's similar to the sort of seasonal forecasting argument, that there's elements of the Earth system that are predictable for longer periods than the atmosphere. So the ocean is predictable for much longer. Components like sea ice or land surfaces have much longer predictability, and using information about those elements allows us to say something longer term about the climate that we're expecting. So as I say, that's like the shove on the pin table there, and the predictable influences that are doing that shove might be things like sea surface temperatures, ice, and land surfaces. Of course, it's quite complex. Several shoves can happen at the same time in different directions potentially, and so statistical models often aren't the best way to get to the bottom of where these shoves are going to be, despite having a long climate record. And so we use dynamical models to get to the bottom of how these shoves, if you like, are going to interact. So this slide is talking about how we make these seasonal forecasts. So it's similar to making a weather forecast. First of all, you need to understand what the world looks like today. So we estimate the initial state of the Earth system, the temperatures, the pressure around the world. We feed this into a model which understands the flow of energy, uses the laws of physics to understand the flow of energy in the climate system, and we run this model forward in time. So that's exactly how we make short-range weather forecasts. The differences are, as I say, there's in the longer timescale, there's more aspects that control that you need to model in order to understand what the climate's likely to do. So things like the ocean, the land surface, and sea ice might not be important for a weather forecasting situation, but they become very important in the seasonal forecasting situation. So we need to make sure that we've got those elements in our model, which means we've got more elements to initialize. And obviously, if we're looking at 6 months ahead rather than a few days ahead, we need to run this model out for longer. So we come to the question of how do we know if it's any good? If we're waiting a long time to so matter of a few months to look at the results of our to look at the outcome compared to the modelling, it's not really possible to wait several years to check whether our model was any good. So what we do in the science is to run what's called a hindcast. This is a diagram showing a particular hindcast from a Met Office model. It's not really important what the parameter is that we've pulled out here. But so what a hindcast does is run the model using historical data over several years of the past. So then we have a sort of experiment where we know what we would have forecasted had we had the model in, for example, 1993, and we can compare that to what we know happened in the climate in that year. So this means that we can do a skill assessment of the model. So we know how well the model can represent the meteorological conditions in the world. So in the context of this project and in the context of industrial decision making, the skill of a model in terms of predicting meteorological output maybe isn't that useful. So what I'm showing with this diagram here is that we have ability to predict fairly broad scale meteorological conditions over Europe in the winter it happens to be. That may or may not be useful in industry decision making. What we're really focusing on in this project is to get to the bottom of whether or not that is useful. So what's the value of this information? And that's what this slide is indicating here. So the value is where the utility interacts with the skill of the system. And we know that in many, so this schematic compares the process of buying a train ticket. In the UK, certainly the earlier you buy your train tickets, the cheaper you can get them. But of course, you might end up not having the need to travel. So you've got a bit of a risk-based decision going on there. And also in the offshore operations, so oil and gas, for example, then you may have some unused assets. So in the example described on the screen there, chartering a ship early means that you may have very reduced costs, but of course you've got that risk as to whether or not you're going to be able to use it, whether or not the conditions are suitable for that use. So within this project, we're trying to get to the bottom of whether or not seasonal forecasts can be used to improve decisions such as this one. And for that, we're going to be needing to use historical forecasts that have been archived, or this hindcast that I was speaking about earlier. So in order to make the best decisions, this hindcast can actually be used alongside cost information coming from the business in order to not just understand the value of the forecast, but also to optimize the decision making. So if you understand your costs, the hindcast can help you understand your risks, and then you can get to the bottom of the value of the forecast. So Ed Steele has a paper under revision and published looking at this subject for the shorter range forecasting, and we're looking in this project at applying it to longer range forecasting, seeing how far we can push this useful forecasting out into the future. So John will be talking later about, in a little bit more detail about this Shell case study, which this is indicating. So what do these services look like at the moment, and where do I expect this to go as part of the project? So there's a range of services already available on seasonal forecasting. They range from a very generic meteorological sort of product or service to a more industry-tailored service. So here I've put very small pictures just to indicate the point. So it's possible already to get hold of maps of meteorological information over sort of relatively large parts of the globe. Depending on your expertise and the assets that you're interested in, this could be the best way to view the information. You can see an awful lot of information over a large space, potentially large period of time, and that may be the best way to make decisions. For an awful lot of industry, that isn't going to be the best way to make decisions. Knowing that it's marginally more likely to be warm over the whole of the northern hemisphere probably isn't really going to cut it. So there's been a lot of work in recent years looking at tailoring this information slightly more to the users. So, for example, drilling down to a particular geographical location, which is sort of indicated here. You can describe the meteorology in more detail, some of the drivers that are going on, so to indicate the confidence in that in the meteorological forecast. Moving further into the industry space, we can start pulling out parameters that we know are particularly important to industry. So things like windy days. Are we expecting more windy days or fewer windy days? So sort of translating that into being able to continue with operations or the price of energy. So it's very possible to turn meteorological parameters into relatively broad scale characteristics interesting to industry and produce graphics based on that. Further into this tailored area, we can translate directly into impacts. So this small diagram here is indicating for UK transport the impacts of the expected impacts in the upcoming winter, for example. So this is a schematic, but things like delay minutes at Heathrow Airport, number of accidents expected on the roads. It's possible to tune long range seasonal forecast information into these sort of impact variables. Where I expect us to head within this project, as well as potentially producing graphics like this if they're useful to decision makers, is data outputs that can be tuned directly into models that are used by industry. So I know, for example, in many industries, the water industry, for example, have their own bespoke models that are used, that inputs climatology, do a process which outputs demand for water, for example. At the moment, they're using climatological information. We could imagine tailoring the information coming out of long-range forecasts to produce data that looks just like the climatological information, but we would expect it to have slightly less variability, and so they can produce a more certain forecast. So that I think is where we should be able to get to within this project, and there's real scope for creating additional value through that process. So that's the summary of the background of long-range forecasts. So it doesn't sound like there was many people in the room who weren't relatively familiar. But are there any questions at this stage? You're very familiar with long-range forecasts.
From the case studies that the weather forecasts for any other country?
I would say that was everyone in the project is using weather information.
Then we need to bring this in addition to that. I mean, there's a habit, there's a tradition, there's a practice of using forecasts. No matter of how do you combine the information you have about the next 5 days with that you have once a month for the month 6 months ahead.
Yeah.
That has benefits because people are used to using data and information from forecasts. But however,
it's difficult to, I suppose what the point you're making is it's potentially difficult to go from using a weather forecast to using a seasonal forecast, because
it's even more interesting to combine them.
Okay.
Not just to change your view of the data that comes out of models, but also to complement the
so potentially making a more seamless service could be sort of something else that's sitting up here. So the other direction which I would expect it to be easier to use the information is if organisations are already using climatology, that you're coming at it from the other direction and improving that climatology. And the seamless argument is another really nice one, that can you extend these short range forecasts. So I think that's kind of the approach that we're looking at with Shell, where they're already using short range forecasts, and we're seeing how far we can stretch the utility using a similar decision-making framework. So 3 minutes, okie doke. So to talk about how Seckley Firm will use the latest science of seasonal forecasting. This is all encompassed within work package 2, which will of course feed into the other work packages, including the case studies. The two main ways in which we'll be pulling in long-range forecast science, seasonal forecast science, is within the use of grand multi-model ensembles. So Alberto has already talked about this. The concept that using more than one model can give you additional information over using one model and better skill. And the other part of it is the optimization of seasonal prediction performance. So that's talking about this processing step. So we're taking these forecasts, processing together to create utility. Wrapped up around all of this will be the communication between this project and other scientific initiatives going on in the world, so that the team is very well connected with the rest of the scientific community, and we'll be expecting to share and use science from elsewhere in the world. Shall I go through this slide? Yes, okay. So to put a little bit of meat on the bones of what this processing steps look like, I have some very small images around this processing slide. So the sorts of ways in which we will expect to improve the processing through the use of teleconnections. So in the Earth system, a phenomena in one part of the world can affect the climate of another part of the world. So there's a work package on making as much use of this process as possible. There's another work package on using information about the large-scale circulation in order to improve our small-scale, tailored forecasts. Bottom right here, this is a diagram that indicates statistics. So statistics can be used to post-process our model output to tailor it to the end user. There's a work package using a methodology that we tend to refer to as unseen. It's also got other names. This is understanding the climatology of very extreme events. So using observational record is relatively limited in terms of the amount of data we have, and so understanding the sort of distribution of very extreme events can be tricky from the observation. So we can use model data to really understand the climatology better. And finally, the tails of the distribution are indicated there. So looking at the predictability of very extreme events within our forecast system, there's going to be a real focus on that. And so I'll leave it there. Are there any questions on work package 2, or you can go right back to the background information as well?
Work package 2, for those who don't know, is about the science, the research, as Emily said, so that's what Emily covered. But thank you very much, Emily, for your presentation. One quick question? Yes?
We said a bit more about the data that typically we would use in forecast, and you alluded to the fact that it's a confidence issue. Do you see that confidence in using seasonal forecast is the same across the range of industry partners you work with, or is it are some people doing more than others?
Some people are certainly doing more than others. I think energy trading is a good example where it's heavily used. Long-range forecasts are heavily used already, and they've got a real ability to hedge and adjust their decision making as time goes on. So it's a really obvious place that it can be used. Apart from that, there is very relatively limited use of the information at the moment. I think there are some groups using it as a sort of climatological basis for their decision making, but certainly trying to ignore the uncertainty unless you're doing that in a reasoned way. So I think we're talking about using what's the threshold at which you start to make a decision in terms of uncertainty with the shell situation. So you're almost turning the forecast into a deterministic forecast because it's a deterministic decision. What needs to be the case is that it's possible to adjust that decision or to be wrong on a number of occasions and right on a number of occasions, and that be okay. So I think in different industries are going to use work with the uncertainty in different ways. Yeah, I think yours will be, but from what I've heard from Ed, up the more trying to make deterministic decisions because you've got operational decisions to make.
Okay. So thank you very much, Emily. And now we have the pleasure to hear from Jan Borink from Tenet about their experience using, I think, weather forecast and how they could use seasonal forecast. I should say this is one of the case studies that we cover in Seclifer, and we'll expand